first objective of this section is learning how to plot points, learning how to graph. And then we need to start out with some basic vocabulary here. We graph on what's called the Cartesian coordinate system. The Cartesian coordinate system. And the Cartesian coordinate system is made up first off of two axes. We have what's called the x-axis and the y-axis. The x-axis being a horizontal line, the y-axis being a vertical line. They intercept in what's called the origin. Anytime we have this system, this x-axis and y-axis intersection is going to divide this Cartesian coordinate system into 4 quadrants. We number these quadrants starting with the top right-hand corner as quadrant 1, and we usually use Roman numerals to do so. And we go counterclockwise to quadrant 2, quadrant 3, and quadrant 4. Now let's talk about actually plotting points. We plot points, or what we refer to as coordinates. Coordinates are found in an ordered pair set. When we say ordered pair, you've got, first off, they're in order. It's usually an X and a Y. It could be an A and a B. It could be an R and an S. We can use any letters there, but they are ordered, alphabetical order. And we notice we call it an ordered pair because there are 2 of them. When we go to graph these values, I remind you that you had an x-axis and you had a y-axis, which could be replaced with an a-axis and a b-axis, or an r-axis and an s-axis. The same way, same alphabetical order. And to plot points, let's start with the ordered pair 2, 3. Your first number is an x, your second number again is a y. The first number tells you how far right or left to go on your x-axis. The second number, how far up or down to go on your y-axis. The same way that you used to build, your bar graphs, to where you would go over what your favorite color is, how many people have that same favorite color, or what red, 2 people like red, blue, 3 people like blue, and so on and so forth. But to plot the point 2, 3, and we're going to let each of these lines count 1. So to plot the point 2, 3, you start at your origin, you travel right 2 spaces, and the second, since it's a positive, you're going to travel up 3 spots. That's the point 2, 3. Let's try some negatives. Let's try -3, +4, which, by the way, that first point was in the first quadrant. -3, +4, the first number tells you, since it's a negative, we're going to travel to the left. So there's your -3, and since the second number is positive, we're going to travel up 4 units. There's the point -3, +4 in the second quadrant. Let's look at the point -6, -2. Since the first number is negative, we're traveling left 1, 2, 3, 4, 5, 6 spaces, and we're going to go, since the second number is negative, we're going to travel down 2 units. And finally, let's try 3, -3. First number being positive, we're going to travel right 3 units and down 3 units, since the second number is negative. 3, -3, and that's in the fourth quadrant. A couple more, 0, 2. Anytime you have a 0 involved, the first number tells you you're going to travel right 0, so you're not moving. And since the second number is positive, we're going to travel up 2, and that's on the y-axis. And finally, let's try -3, -0. -3, 0 means you would travel left 3 units and up 0 units, so that would be on your x-axis. Okay, the next objective of this section is determining if a given ordered pair is a solution to an equation. I remind you that when we're given an ordered pair, that again it is ordered, it's in alphabetical order. So in this problem we have x's and y's, so my ordered pair would represent an x-y relationship. So I want to determine, here's my equation. Notice I have an equal sign. I want to determine if 7, 2 and -3, -2 are solutions. We're going to do it one at a time. We'll start with 7, 2. Notice your x is 7, your y is 2. And to determine if this is a solution, we simply take out the x and y and plug in our 7 and our 2 in that order. So we have now, instead of 2x, we have 2 times 7. Notice anytime you have a number letter relationship next to each other, that does indicate multiplication. plus 3 times 2 is equal to 20. And I'm going to put a question mark there because I'm unsure. That's what we're testing to see, does it equal 20? We plug this in, we now evaluate. Remember, order of operations, parentheses, exponents, multiply, divide, add, subtract. We're going to multiply because all we have here is multiplication and addition. 2 times 7 gives me 14, plus 3 times 2 gives me 6. And I still want to determine if does that equal 20. And as we do 14 plus 6, we do see that we have 20 equals 20, which is a true statement. So therefore, 7, 2 is a solution to that equation. Next, let's test the -3, -2. We take out x, we put in a -3, so we now have 2 times -3 plus 3 times -2 equals 20. Evaluating that gives me -6 plus -6 equals 20. And again, you can put question marks there if you'd like, because we're unsure. And we see actually that -12 equals 20 is a false statement. That is not true. That symbol means not equal to. So therefore, -3, -2 is not a solution to that equation. In this next problem, I want to determine if 2 -4 is a solution to 5b minus 3a equals 34. And a reminder that anytime you have an ordered pair, they are in alphabetical order. So in this case, since we're dealing with a's and b's, my a would be 2, and my b would be -4. So as we plug these in, we have 5 times -4 minus 3 times 2 equals 34. Be extremely cautious about order there. I do put a question mark because I'm not sure. 5 times -4 gives you a -20. And here you've got two options. I treat this as a -3. You have -3 times +2 gives me a -6 or a -6. So I have -20 minus 6 equals 34, which is not true because -20 minus 6 is actually equal to -26, and that is not equal to -34. Therefore, 2 -4 would not be a solution to this equation. Okay, in this next example, we're kind of combining the two things that we've done thus far. What I want to do is I want to show that -4, 3, 0, 1, and 4, -1 are all three solutions to this equation. Then we're actually going to turn around and graph these three solutions and show you what the solution, the set of all the solutions looks like. Plug in the first one, plug in -4. I have y, or excuse me, not y, but we have plug in 3 for y equals 1 minus 1/2 times -4, question mark. So you now have 3 is equal to 1, and -1/2 times -4 is a positive because you have negative times negative, +2. And we do know that 3 equals 1 minus, or 1 plus 2 is a true statement. We do the same thing with our next solution. We have, and again, we're plugging in here, y equals 1 minus 1/2 times, in this case, 0. And we already know that 1/2 times 0 is actually 0. So 1 minus 0 will give you 1 equals 1, which is also a true statement. And our third one that we're plugging in, our y value is -1 equals 1 minus 1/2 times 4. -1 is equal to 1, and that's question mark because, again, we're still questioning it. 1 minus half of 4, 1/2 times 4 is 2. And 1 minus 2 does equal -1. So all three of those are solutions to this equation. Now watch what happens when we actually plot these three solutions on our Cartesian coordinate system, or our XY plane. -4, 3, again, I remind you, you go left, 1, 2, 3, 4, and up 3. You go 0, left and right 0, and up 1. And you're going to go right, start at your origin, right, 1, 2, 3, 4, and down 1. And you notice something, that there's a pattern to it. That each of these solutions lies in a straight line. And these are three of actually an infinite number of solutions to this y equals 1 minus 1/2 x. There's an infinite number of solutions to that. And what we can actually do is we can take and we could actually draw a straight line. Draw a straight line through these points, and this straight line would be representative of each and every solution to that equation. So once we find that pattern and draw that line, we could actually see other potential solutions to this equation. Some of them being, let's look at this. Looks like there's a solution here, which -2, +2. And you could test these, and each of them would be a solution. -2, +2 is a solution. The 0.20 would be a solution. The 0.6, -2 would be a solution. And once you have this pattern established, you actually have each and every solution to that what we call a linear equation, which we'll talk about more later on. Okay, in this next example, we're actually asked to graph an equation, but they're not giving us a set of possible solutions. All they give us is an equation. And one way that these can be graphed is by using what we call an XY table. And in our XY table, what we're going to do is we're actually going to find our own solutions. And virtually any equation can be graphed in this manner. So what we're going to do is we're going to find some x values, and we're going to choose our own. Choose our own x values to plug into this equation. And once we plug those x values in, it's going to yield y values that we can use to actually graph this y equals 1/2 x. Here's the thing, when choosing x values, I highly recommend to choose x values that's actually going to fit on your graph. Notice here's my x-axis. Here's the x values 1, 2, 3, 4, 5, 6, and 7. If we chose an x value like 10, it's not going to fit on our graph. So be very cautious of where your graph is located and what's actually going to fit on it. So I'm going to choose x values. I'm going to choose 0 is always a good one to plug in. We'll choose maybe 1, 2, and -1 and -2. You can choose any x values that you like. The ones that are going to work into your equation easier, I could have chosen some different ones that might have worked a little bit better, but we'll stick with these. And here's what we're going to do. We're going to take each of those x values, such as the first one, x equals 0. We're going to take and we're going to plug that in. And what I now have, instead of y equals 1/2 x, I have y equals 1/2 times 0. And we all know that 1/2 times 0 is 0. My next x value is 1, and I'm going to do the exact same thing with this. Instead of y equals 1/2 x, I now have y equals 1/2 times 1, which is 1/2. My third x value is 2. I take and do the same thing for it. We're just going to plug each of these x values in. 1/2 times 2 gives me 1. And we're doing the same thing for each of these x values, and I'll go ahead and finish filling your table in. 1/2 times -1 is 1/2, or -1/2, and 1/2 times -2 is -1. Now what you actually have in your table is a list of x, y ordered pairs that are actually solutions here. When x is 0, y is 0, that's an ordered pair solution. You could actually come out to the side and write it as an ordered pair if you'd like. But gives you a whole list of actual solutions to this equation. We're going to take those 5 solutions and we're going to plot the points. When x is 0, y is 0, you have the point. Now this is a little different. You have the point 1, 1/2, so we're going to have to go over one box and up 1/2 box. Where for 2, 1, we go over 2 and go up 1. For -1, -1/2, we go left 1 and down half a box. And for -2, -1, we go left 2 and down 1. And you see again, there's a pattern there. There's actually a linear pattern. And the reason this is a linear pattern is because this is a linear equation. And when we say linear, we see the root word of linear is line. So anytime we have this straight line action like we have here, then we have a linear equation. And something else that you have when you have a linear equation, notice that from one box, let's take these two, from one box to the next, or from one dot to the next, or point to the point, I go up one box over 2 boxes. If you'd like to follow the same pattern, you can actually find other points that lie along this line. And that might be a little bit easier to graph once you have those other points. Let's take and draw my line between these points now. And now you have the graph of y equals 1/2 x. And as before, you see a picture of all the solutions. So now we could actually say, you know what, -1, 2, 3, 4, 5, -6 right here -6, -3 would also be a solution to this equation. Let's graph one more of these linear equations. Reminder that you must follow order of operations. You're going to, again, create a t-table or an xy table. You can choose any x values you want as long as they're going to fit on your graph. I'm going to choose -2, -1, 0, 1, and 3. Just to show you that it doesn't matter what points you pick. You can choose any points. Those are x values, so one at a time we're going to substitute those in for our x. So substituting in -2, we now have y equals 2 times -2 plus 1. Order of operations, 2 times -2 would be -4 plus 1, which gives me -3. Your next x value is -1, so we have y equals 2 times -1 plus 1, which is -2 plus 1, which is actually -1. Your next x value is 0, so you have 2 times 0 plus 1. 2 times 0 is 0 plus 1, which is 1. Your next x value, and you catch on what I'm doing here. You just keep plugging in those x values, and I'll finish filling your table out here. When you plug in 1, you'll get 3. When you plug in 3, you'll get 7. These are ordered pair points: -2, -3, -1, -1, 0, 1, 1, 3, and 3, 7. We plot those ordered pairs: -2, -3, -1, -1, 0, 1, 1, 3, and 3, 7. 1, 2, 3, 4, 5, 6. Just barely fit on my graph. We can connect our dots and get a pictorial view of what this graph actually looks like linear-wise. And it does follow that straight line. And a lot of times you'll notice that we'll put arrows on each end because we know that that line's not going to stop here. It's not going to stop here. It's going to continue going because there's other answers further down the line. Something else that we noticed, that the point I skipped here, notice I went from 0 to 1 to 3. I skipped 2, but we could actually, from our graph here, we can see that if I did plug in 2, that I would get right here, if I plugged in 2, I would have gotten 5. So you do see a picture of all the other solutions that are going to be on your line. Okay, on this next equation that they're asking us to graph, notice it doesn't look like what the other equations have looked like. Instead of having y equals, you have, it's in what's called standard form. We'll talk more about it later, but you have your x's and y's on the same side. Before we start plugging into this equation, I would like to show you how that you could get that in the other form that you had the previous problems in. Here's the way that I work these. This is my shortcut. Here you have what's called terms. You have 3 terms. And my rule of thumb is I can move a term across an equal sign as long as I remember this. If a term is positive on one side of an equal sign, if I move it to the other side of the equal sign, I need to change it to a negative. If one of these 3 terms were negative and I wanted to move it to the other side, I'd have to change it to a positive. So think about what I want this to look like. I want, instead of what I have, I want y equals something. So here's how I'm going to get that. I'm going to take my 3x term. Okay, I'm leaving y alone to begin with. I'm going to take my 3x term and I'm going to move it to the other side of the equal sign first. 5y stays put. 3x is actually going to become -3x. And 10, since it didn't have a sign in front of it, it's understood to be a positive 10. So I'm going to leave that as plus 10. And I'm nearly done already. In that one step, I got rid of a whole term, and now all I've got to get rid of is my 5. And if you remember back from basic algebra, to solve this, to get y by itself, in order to get rid of 5, since they're being multiplied, I can move that 5 to the other side by using division. So what I'm going to do is, in order to cancel out, in order to get rid of this 5, since they're being multiplied, I'm coming to the other side, and I'm going to divide everything, each term, by that number. So now my 5 is gone, and I'm going to clean this up a little bit. I divided each by 5. Negative 3 divided by 5 will give you a decimal. So I'm going to leave that as negative 3 divided by 5, which is negative 3/5. I'll leave my x. Now here I can divide. 10 divided by 5 will give me a 2. And notice now we actually have the exact same form as what we had in the previous problems. So in order to graph this, let me get my graph paper ready. I'm going to do a t-table again, an xy table. I'm going to plug in anything I want for my x's. And now let me give you a little bit of advice here. 0 is always something good to plug in. 0 is always easy to plug in. When you're multiplying by a fraction, we're having to take negative 3/5 of x. Whatever this bottom number is, if you'll plug in multiples of that number, it's going to be much easier to multiply out. What I mean by that is multiples of 5, which would be 5, 10, negative 5, negative 10. Works out much cleaner. When I plug in 0, we'll do it right here, y equals negative 3/5 times 0 plus 2. Negative 3/5 times 0 is 0, plus 2 would give me 2. Now watch how much better this works out. When I plug in positive 5, I've got to do negative 3/5 times 5. And to multiply fractions, let's get a top and a bottom there. So negative 3/5 times 5 plus 2. When you're multiplying fractions, notice here I can cross cancel my 5s. And that's the reason it's so much better to use multiples of 5. It's going to cross cancel that for you. So I now have y equals, multiplying tops and bottoms, I have negative 3 over 1, or just negative 3, plus 2, which gives me negative 1. Plugging in 10 gives me negative 3/5 times multiplying fractions of top and bottom, plus 2. 5 and 10 cross cancel gives me 1 and 2. Negative 3 times 2 is negative 6 over 1, or just negative 6. Negative 6 plus 2 is negative 4. And I'll finish filling out the table for you. When you plug in negative 5, you're going to get, I believe it would be 17. Or excuse me, scratch that. When you plug in negative 5, you're actually going to get 3 plus 2, which is 5. When you plug in negative 10, you're going to get 8. Now notice my graph paper here doesn't quite extend to the the 10, negative 4, and the negative 10, 8. So what I'm going to do, I'm just going to graph what I've got there. 3 points are actually, for a linear equation, 3 points are plenty. That's sufficient. So I have the point 0, 2. I have the point 1, 2, 3, 4, 5, negative 1. The point negative 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. Those are the only 3 that's going to fit, but like I said, that will be sufficient because I can test that out and see that those 3 do lie in a straight line. So I can be confident that that is my solution set there. Okay, our last objective for this lesson is we're going to graph some nonlinear. And we probably, if we think real hard, we'll know what we mean by nonlinear. Up to this point, everything we graphed has been linear. It's been a straight line. So now we're going to graph some things that aren't straight lines, is all it is. And the process that we follow is identical to what we did before. You might want to have a few more than 3 values, though, because you won't have a straight line. You will have some sort of pattern, but you won't have a straight line. So you might want to plug in a few extras. I'm going to use the 5 values that I've used on several of these, negative 2, negative 1, 0, and 1 and 2 for my x's. Plug those in and find my y values the same way I did before. Be careful, though, with your negatives. Here, we're plugging in negative 2 for my x's, so I now have y equals 4 minus. Now, if you think about order of operations, you always have to work exponents before you subtract. So what you've got here, make sure that you do your exponents before you combine this minus minus, a common error a lot of people make. So that'll be 4 minus. The minus stays until you square this negative. Negative 2 squared is negative 2 times negative 2, which is 4. 4 minus 4 gives you 0. Now we plug in negative 1. We have 4 minus negative 1 squared, which will be 4 minus negative 1 squared is positive 1, which gives us 3. 4 minus 0 squared, and I think we already know what that's going to be. 0 squared is 0, so 4 minus 0 will give us 4. I'll finish your table. 4 minus 1 squared will be 4 minus 1, which is 3. and 4 minus 2 squared, but 4 minus 4, which is 0. And notice we can see here that this is definitely not linear. If you look at your table of values or your XY table. When I plug in -2, I get 0. When I plug in -1, it's -1 comma 3, 0 comma 4, 1 comma 3, and 2 comma 0. And if we actually plug in some more values here, if you're not satisfied with how many values you plugged in, you can always go back and plug in some extra to get a better picture. If you did plug in some more values, let's say that you plug in -3, you're actually going to get -5 here. 1, 2, 3, 4, 5. And you can test that and see that that is true. And if you plug in +3, you would actually also get -5. And you could keep plugging in other values until you got as good of a picture as what you want. This is what's actually called a parabola. You don't have to know that at this point. We'll talk more about quadratic equations and parabolas later on. But if you connect your dots, you're going to get a picture of what 4 minus x squared actually looks like, and it is definitely a nonlinear graph. The next nonlinear graph that we're going to do is y equals 2 divided by x, or 2 over x. And I would be careful about my xy values that I chose here. I told you the 0 is a good thing to plug in, but I don't know if you remember, but division by 0 is always undefined. We can't divide by 0, so we're not going to be able to plug that in here. So let's plug in some values such as, and think about what you're doing. You're 2 divided by a number. I'm going to plug in 1, 2, 4, and plug in those same negative values, -1, -2, and -4, and show you what happens here. Y equals 2 divided by x. So y equals 2 divided by 1 is 2. 2 divided by 2 is 1. And 2 divided by 4 is actually 0.5, or the way that I do it, 2 divided by 4, if you can't divide it without getting a decimal, just leave it as fraction form and reduce it. That's 1/2. 2 divided by -1 is -2. 2 divided by -2 is -1. And 2 divided by -4 actually is -1/2. And we're going to plot these, but more than likely we're going to go back and put some more values because I don't think this will be enough. When I plug in 1, I get 2. When I plug in 2, I get 1. When I plug in 4, I get 1/2. When I plug in -1, I get -2. When I plug in -2, I get -1. When I plug in -4, I get -1/2. Really doesn't give me a good picture because I'm not really sure what's happening here in between. So what you can actually do, and you don't have to plug in whole numbers here, you could go back and if you like plug in numbers such as 1/2. And I remind you, in order to do 2 divided by 1/2, you'll watch this. 2 divided by 1/2, to plug that in, a fraction bar is simply a division symbol. And you can type this straight into your calculator and find this answer, but here's what you're actually doing. To divide two fractions, and we can treat this top 2 over 1 as a fraction as well. We could rewrite this as 2 over 1 divided by 1 over 2. To divide two fractions, you flip the second one and multiply. So that's 2 over 1 times 2 over 1, which is 4 over 1, or just 4. So when I plug in 1/2, I actually get, notice my x value is 1/2, my y value is 1, 2, 3, 4. You can plug in more values. You can plug in -1/2, you're going to get -4. You could plug in, and you can test me on this, but you could plug in 1/3, and you're going to get 1, 2, 3, 4, 5, 6. If over 1/3 of a box, go up 6. If you plug in 6, you're actually going to get 1/3. 2 divided by 6 is the same thing as 1/3. So 1, 2, 3, 4, 5, 6, you're actually going to get 1/3. And now we're getting a better picture of what this graph's doing. And notice what I told you a while ago. This graph will never, you can't plug in 0. So if we connect our dots here, you've got a graph that actually jumps. It jumps from down here up to, in the third quadrant, up to your fourth quadrant. So there's the graph actually of y equals 2 divided by x. And the last graph that we're doing for this section is what's called y equals the absolute value of x. Anytime you have what's called absolute value bars around a number or a value, what we're going to do with that value is simply make it positive. If it's a negative, you make it positive. If it's already positive, you leave it positive. So we're going to plug in some x values. We're going to obtain our y values. And this is going to be pretty easy to plug in. We take out x, we put in -2, y equals the absolute value of -2, and I told you that simply makes it positive. Absolute value of -1 is +1, absolute value of 0 is 0. +1, we leave it positive, +2, we leave it positive. When we plug in -2, we got +2. When we plug in -1, we got +1. Plug in 0, we got 0. Now here's where it changes. It looks linear. But when we plug in 1, we got 1. When we plug in 2, we got 2. And you can extend that on. If you plug in 3, you get 3. If you plug in 4, you get 4. If you plug in -3, you get 3. If you plug in -4, you get 4. And here we see the graph of y equals the absolute value of x, which is actually a V-shaped graph.